Chapter 1. A Lonely Existence. People aren't often alone. We gather in villages, towns, and cities. We join together for meetings, reunions, or just to chat. That's not the case with comets and asteroids. They live lonely lives. See those chunks of rock floating beyond Mars? They're asteroids orbiting the Sun millions of miles from Earth. The situation is the same for comets. The distant clumps of dust and ice have been drifting alone for most of their existence. Asteroids. Comets. Every now and then, comets fly by Earth close enough to be seen with the naked eye. As a comet travels toward the Sun, it leaves behind a huge plume of dust and rock. Sometimes comets and asteroids get too close for comfort. A piece of an asteroid may pass through Earth's atmosphere as a meteor. If it survives its fiery fall to Earth, it's called a meteorite. Luckily, most comets and asteroids never get near Earth. We learn about them as we peer through telescopes and receive spacecraft signals. Although they're fascinating, life is safer when comets and asteroids keep their distance. Chapter 2. Home Sweet Solar System. Look up on a clear, dark night and you'll see a bright, misty band of stars spreading across the sky. That's the center of our galaxy, the Milky Way. With its planets, comets, and asteroids, our solar system is a tiny part of the Milky Way. To understand how the solar system came to be, let's travel back 5 billion years when there was no solar system. Instead, giant stars blazed within gigantic clouds of gas and dust. Occasionally, a supergiant star would explode. The explosion, called a supernova, probably started the formation of our solar system. Shock waves from the explosion pushed together the cloud's gas and dust. Gravity then began pulling the gas and dust into clumps. Over time, a huge rotating disk took shape. As the disk turned, dust clumped together and became rocks. The rocks broke apart and smashed back together. The process repeated over and over again for millions of years. The clumps and rocks grew to enormous sizes. At some point, a very large mass in the center of the disk ignited, and the Sun was born. Other clumps formed the 8 main planets and the dwarf planets Ceres, Pluto, and Eris. Asteroids and comets formed from the same material that made the planets. Asteroids are mostly rock and metal. They formed closer to the Sun. Comets are made up of ice, dust, and organic materials. They formed much farther from the Sun. In the early days of the solar system, trillions of asteroids and comets whizzed through space. They crashed into the planets and each other. Eventually, they settled in places far from Earth. One group of comets now makes up the Kuiper Belt. The Kuiper Belt encircles the solar system. Starting at Neptune's orbit, the belt extends billions of miles into space. Another group of comets gathers farther out in the Oort cloud. Found more than 200 trillion miles, 322 trillion kilometers from Earth, the Oort cloud completely surrounds our solar system. Kuiper Belt, our solar system, Oort cloud. Most asteroids are located within the asteroid belt. This belt of rocky debris lies between Mars and Jupiter. The asteroids range in size from small boulders to mountains. There may be millions of asteroids within the asteroid belt. Fact: more than 300,000 asteroids have been found by astronomers. Of these, at least 26 are larger than 124 miles, 200 kilometers wide. Some asteroids are so large they have names, such as Vesta, Pallas, and Hygeia. Ceres, named after the Roman goddess of grain, is so large that it's considered a dwarf planet. Its length would almost stretch across the state of Montana. Asteroids can be put into 3 groups: stony, iron-nickel, and a mixture of the two. Of all the known asteroids, only a small number are iron-nickel. Fact: the word asteroid comes from 2 Greek words. Aster means star, and oid means shape. Iron-nickel asteroids are mostly metal. In addition to iron and nickel, they contain platinum, cobalt, and manganese. They also contain minerals such as sulfur. Mining asteroids. Once all the metal on Earth is mined, where will future supplies come from? Asteroids. Even a small iron-nickel asteroid can contain 30 billion tons, 27 billion metric tons of rock and metal ore. It would take 100 NASA space shuttles 6 million trips each to move half of an asteroid's ore to Earth. Unlike asteroids, the rock in a comet is mostly dust, tiny grains of sand, and ice. Most of the ice is made of water, but some is made of carbon dioxide. Carbon dioxide ice is also known as dry ice. There's also organic material in comets. It looks like coal dust or soot from a fire. Where did the sooty organic material come from? It came from the large clouds that formed long before our solar system. Fact: the Giotto space probe snapped a picture of a comet's main body called the nucleus. The comet's nucleus was 9 miles, 14 kilometers long, black and shaped like a peanut. After making several trips around the sun, a comet's ice forms a crust of rock, dust, and organic material. Comets are some of the darkest objects in the solar system. The black asphalt of a parking lot reflects more light than a deep space comet. Comets aren't always dark and difficult to see. When a comet nears the sun, ice and dust stream off of its nucleus to form a coma and tail. The tail of dust particles and ice reflects light from the sun. Comet tails range in length from tens of thousands to millions of miles long. As Earth moves through a comet's plume, particles of dust and rock burn up in the atmosphere. These bits of blazing dust and rock are known as meteors. During the Great Meteor Shower of 1835, shooting stars fell at the rate of hundreds of thousands an hour. The shower was caused by Earth colliding with the densest part of a comet's trail of debris. Within the asteroid belt, asteroids often collide. When one hits another, chunks break off. During really big collisions, entire asteroids shatter into smaller pieces. If the orbits of the pieces cross Earth's orbit, look out for a collision. Meteorites have shown up all over the world. More than 100 large impact craters have been found. Impact craters form when a meteorite strikes Earth with great force. The largest one ever found is about 186 miles, 300 kilometers across. What makes up a meteorite? A chunk of rock that hits Earth is known as a meteorite. Usually these rocks aren't from comets, though. Meteorites are chunks of stone or iron and nickel that have broken off of asteroids. Chapter 3. Comet Tails. Ancient writings and paintings prove that comets were seen long ago. But before the age of science and reason, no one knew what comets were. Early stargazers were startled when they saw lights where none had been before. Were the lights angels? Could they be warning signs from an angry god? Ancient people believed comets were bearers of bad news. When a comet appeared, most people thought a war, disease, or natural disaster was sure to follow. Fact: the word disaster has its roots in the ancient belief that comets brought bad news. Disaster is Greek for bad star. Comets appeared at the same time as these events. A war between two Chinese kings in 1059 BC, an earthquake and tidal wave in Greece in 372 BC, Napoleon's invasion of Russia in 1811. Of course, comets didn't cause any of these events. Nevertheless, they were blamed for bringing bad luck. English astronomer Edmund Halley made an important discovery about comets in the early 1700s. He discovered comets that appeared in different centuries were actually the same comet showing up over and over again. Halley knew that the planets orbited the sun along oval-shaped paths called ellipses. He thought comets might do the same. He believed comets loop around the sun on a regular basis called a period. Later in life, Halley thought about the comets that appeared in 1531, 1607, and 1682. Halley guessed the 3 comets were actually just one. He predicted the comet would reappear in December of 1758. Although Halley didn't live to see it, his prediction was right. A comet blazed brightly in the sky on December 25, 1758. Since Halley's death, historians and astronomers have looked over ancient manuscripts that mention comets. We now know that Halley's comet has made at least 28 visits to Earth, reappearing once every 76 years. Halley's comet will be making an appearance again in 2061. How old will you be when the famous comet appears again? Because comets orbit the sun, they regularly visit Earth. But because of their long orbits, regular may not mean frequent. Comet Hale-Bopp, which amazed skywatchers in 1997, last visited the Earth around 2400 BC. Chapter 4. Crash Landing. During the first 500 million years of its existence, Earth had little oxygen, water, or organic material. Without these substances, there was only a small chance that life would develop. Long ago, Earth was bombarded by comets large and small. The colliding comets supplied Earth with materials needed for life, including carbon and water. In 1986, the Giotto space probe flew through the tail of Halley's Comet. The probe analyzed the material streaming from the comet's nucleus and coma. The comet was 80% water. It also contained carbon monoxide, methane, and ammonia. All of these compounds are common on Earth. 18 years after Giotto, NASA's Stardust spacecraft chased down the comet Wild 2. Stardust's job was to collect tiny particles from the comet's tail. In the wispy threads of comet dust, the spacecraft found traces of glycine, an organic compound. Without glycine, life on Earth could not exist. Some scientists think that the building blocks of life first formed in outer space. Stardust's discovery supports this belief. Life-creating molecules were carried from space to Earth by crashing comets. Perhaps comets carried these same molecules to other planets too. If these organic molecules exist on other planets, life may exist elsewhere in the galaxy. Comets crashed to Earth over a long time period. But the collisions happened less often over time. Earth's surface became stable and life took hold. Oceans formed and aquatic plants grew. After hundreds of millions of years, strange creatures evolved and swam through the warm seas. More time passed and dinosaurs came to rule Earth. For tens of millions of years they slithered, swam, and stomped across the face of the planet. Then, suddenly, they were gone. Why did dinosaurs die out so quickly? Recent discoveries pin the blame on a massive comet or asteroid strike. 65 million years ago, a huge hunk of rock struck Earth. The collision blasted a crater 100 miles, 161 kilometers wide, and 5 miles, 8 kilometers deep. Halfway around the world, the ground trembled as rock, dust, and earth surged upward in a giant cloud. The shock wave from the explosion forced the seas into a tsunami thousands of feet high. Meanwhile, hurricane-force winds carrying rock and dust shredded everything in its path. The intense heat of the impact ignited fires across the planet. Smoke filled the air, making breathing difficult for any animals left alive. The comet collision doomed the dinosaurs. Many died quickly. A thick cloud of dust blotted out the sun for months or possibly years. Plants died from lack of sunlight, so plant-eating dinosaurs didn't have much food. Water froze, even at the equator. Dinosaur extinction, however, was good news for the smaller creatures that survived. With dinosaurs no longer around, small rodents were less likely to be eaten. As millions of years passed, the small mammals that survived slowly evolved into larger ones. Some took to the trees and became ape-like primates. Millions of years later, they came down from the trees and began to walk upright. While the Great Collision 65 million years ago brought death to the dinosaurs, it allowed our ancestors to survive and thrive. If it wasn't for the collision, humans might not be here today. If you look up at the night sky, you might see a shooting star. These meteors streak through the sky on a regular basis. Small meteorites hit Earth every few decades. A bigger object might strike once every 100,000 years. Only once every 100 million years does our planet get clobbered by a rock big enough to destroy life on a large scale. Comets colliding with planets aren't just ancient history. In 1994, the world watched as fragments of the comet Shoemaker-Levy plowed into Jupiter. At least 21 chunks slammed into the planet's atmosphere at speeds of about 129,000 miles, 207,605 kilometers per hour. The largest fragments tore a hole in the cloud layer big enough to hold 2 Earths. Needless to say, scientists, and everyone else, hope a collision won't happen anytime soon. Space agencies are working to prevent a future strike. They track comets, asteroids, and meteors. They figure out whether any will collide with Earth. What if astronomers knew an asteroid would hit Earth in several years? With ample warning, we could nudge an asteroid away from a collision course. For a forceful nudge, nuclear bombs could explode next to the asteroid. The explosion would be close enough to shift the asteroid off course, but not close enough to shatter it. Another option would be to crash a very large spacecraft into the asteroid. The force of the nudge might be strong enough to push it away from its collision course. An asteroid could also be gently nudged by powerful spacecraft that have landed on its surface. Constantly running the spacecraft's engines would provide a steady force to move the asteroid a few inches every year. As the years passed, the asteroid would be inched into an orbit that would miss Earth. If a tracking system discovered a comet or asteroid heading directly for Earth, timing would be crucial. Without enough warning, a powerful nuclear bomb might only shatter an asteroid into chunks, and being pummeled by chunks might be worse than being struck by one large rock. Chapter 5. Wonders never cease. Comets and asteroids exist far from Earth. Even so, we know a lot about them. They formed billions of years ago from the same substances that make up our own planet. Asteroids are rocky and sometimes made of iron and nickel. Comets are made up of dust, organic compounds, and ice. The solar system is a place of tremendous energy and action. Comets gather speed as they approach the sun. Asteroids tumble and occasionally collide in the asteroid belt beyond Mars. Sometimes asteroids and comets visit Earth. As comets fly by, their brilliant plumes of water and dust spread across the sky. Asteroid chunks collide with Earth's atmosphere, burning up in streaks of fire. In your lifetime, a chunk of space rock may fall to Earth. If you're lucky, you might see Halley's Comet. It's even possible that you'll watch live video of astronauts walking across the surface of a far-off asteroid. In a universe as grand as ours, the wonders never cease.